Okay, so let's do this example here. We've got two examples, and we're going to simplify all of these expressions. Okay, so let's start with the first example. We've got A and B, and what we're going to do is we're going to combine all like terms until we can't do anymore. So in this case, are these like terms? So that's what we've got to figure out. Are these like terms? Okay, so we've got an A here, right? An A here. So any terms, again, to be like terms, you have to have the exact same number of you have to have the exact same variable coefficients in the same number, right? Which meaning if you have three A's, not three A's, but how do I want to say this? Let's just stick with this. Let's just say the exact same variables, right? The same number of variable factors, right? The exact same number of the exact same variable coefficients, and with the exact same number of variable factors. Okay, so I'll say it that way. So here we've got an A here, and we've got an A here, we've got an A here. So these are all like terms because they all have just one A, right? So we can combine these. Okay, so if I have 5 of these plus 2 of these minus 1 of these, so I can write this as what? 5 plus 2 minus 1 A, right? Because I've got, let's say, 5 bananas plus 2 bananas minus a banana, right? I mean, whatever. So if I add these two, I get 7, and then minus 1, I get 6. So the answer is just 6A, and I'm done. It's simplified. Okay. Now what about this one? Now what are the like terms? Okay. Well, all the terms that have the same variable factors. Well, we've got an x here, and we've got an x here. So these two terms are like factors. So let's combine those two. So these are like terms. And then what are some other like terms? Well, we've got a y here, we've got a term here with a y, and we've got a term here with a y. So these are like terms. But then we also got a constant term. We got two constant terms. We got a constant term here and here. So those are like terms. So we can combine all of those. So if we do, what do we end up getting? Well, we end up getting 3x minus 2x, which gives us just 1x. And then if we get 5y, so 5y plus y is 6y. And then we've got 8 minus 12. So again, if it's appropriate, you could change these all to plus negatives, right? So then, again, we have 8 plus a negative 12, which gives us what? A negative 4, so we can write minus 4. And so this is simplified. We can't combine it any further. Okay? So now, what about this example? Now, in these examples, we're going to use the distributive property to simplify these, because notice that none of these inside parentheses have like terms. Okay? So, but we can still simplify these by using the distributive property. Okay? So, for example, we're going to distribute the 3 to each term, right? That's what the distributive property tells us to do, right? So then this will give us 15x minus 6. So we're done. Now, what about this one? We're going to do the same thing, but now we're going to distribute the negative 7 to all 3 terms. And so this is going to be negative 7 times x plus negative 7 times y minus negative 7 times 3z. Now, what happens here? This becomes a negative 7x minus 7y plus 21z. Okay? So again, be careful of the signs. Okay, always remember multiplying sign numbers, what happens. Okay. Now the last one here, we got a negative of this whole thing. So again, remember, there's always an assumed, if there's a negative here, we can always look at it as a -1. So now what we're going to do is we're going to distribute the -1 to each term. So this would be -1 times -3x plus -1 times 4, right? If you want to think of it this way, that's fine. And then this gives us positive 3x, and this gives us minus 4. And so that becomes our final answer. And that's it. So again, make sure you practice and let me know if you have any questions.